In this lesson, we will talk about Gauss-Jordan elimination, which will be very similar to what we just did. When we solved before using Gaussian elimination, we had to write our augmented matrices in row echelon form. Now we're going to write them in reduced row echelon form, which means in addition to having our leading ones and zeros underneath the ones, we now also want zeros above any of the leading ones. So after writing the augmented matrix, we can just solve the system by looking at it, because we'll have x equals whatever the x value is, y equal to whatever the y value is, and z equal to whatever the z value is. So I did use the exact same examples that we did in our previous video because I wanted you to see the difference between those two forms. So if you have your notes from that video, I would get those out to make the math a little bit easier. And this is where we ended last time. And last time we said it's in the correct form because we have ones here and we have a 0. But this 3/2 is now a problem if I'm using Gauss-Jordan elimination. I need to turn that into a 0. So I'm going to take negative 3/2 times R2 plus R1 to get my new R1. So negative 3/2 times 0 is 0 plus 1 gives me 1. Negative 3/2 times 1 is negative 3/2 plus 3/2, that gives me 0. Negative 3/2 times 1 is negative 3/2 plus 7/2 gives me 4/2, which is 2. Notice this one didn't change. And now, instead of having to use back substitution, this equation is x plus 0y equals 2, so x equals 2. This equation is 0 plus 1y equals 1, so y equals 1, and my solution is 2, 1. This is the same solution I had before, but now notice I didn't have to plug it back into any equations because I had essentially the identity matrix here, which we'll talk more about the identity matrix later. The second example that we did together, I'm going to do the first steps just as we did before. And when we did this question before, this was our final solution, and we, from here, used back substitution to solve. So what I want to do now is I want to, instead of using back substitution, I want to use Gauss-Jordan elimination, which means I need these values to be zeros. So I'm going to start by making this a 0. So I'm going to take negative 1/2 times R3. I'm going to add that to R2 to make my new R2. I already have row 3 exactly where I want it. We'll deal with row 1 in a little bit, so row 1 I'm just going to recopy. Row 3 I'm going to recopy. And row 2 is going to be half of row 3 plus row 2. So half of row 3 plus row 2, half of row 3 plus row 2, half of row 3 negative plus row 2, half of row 3, change the sign to make it 2, plus row 2, that gives me 1/2. So now I've got row 3 exactly where I want it, I have row 2 exactly where I want it, and now I have to change some things to get row 1 exactly where I want it. To make my second term a 0, I'm going to take negative 2 times row 2 plus row 1 to be my new row 1. Everything else will remain the same. And I'll take negative 2 times row 2, so that's 0 plus 1. Negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 0 is 0, plus 1 is 1. And negative 2 times 1/2 is negative 1, plus 1 is negative 1. Or plus 0 is negative 1. So now I'm really close, but I really need to make this a 0 also, because it's not quite there yet. So now I'm going to take negative R3 plus R1 to be my new R1. Notice row 2 and row 3 will remain the same. So I'm going to take the opposite of R3 plus R1, so the opposite of 0 plus 1, the opposite of 0 plus 0, the opposite of 1 plus 1, and the opposite of negative 4, which is 4, plus negative 1, which is 3. And now notice I have all zeros except for those leading ones that are in a diagonal, which means x is 3, y is 1/2, and z is -4, which means that is my ordered triple is 3, 1/2, -4. Go ahead and finish this question so you can start with the solution that we ended with previously. And this is the solution that I ended with previously, so you can start with this solution and just finish by turning this into reduced row echelon form, and that would of course be using Gauss-Jordan elimination. So go ahead and press pause from here and rearrange that so that you have it in reduced row echelon form to find your solution. So notice row 3 is exactly where I want it. I've got my zeros and my 1. Row 2, not quite where I want it. I have a 1 here, but I really don't want this to be a 3. So I'm going to take 3 times row 1, nope, -3 times row 3. And the reason I'm using row 3 instead of row 1 is I don't want to mess with this 0. And notice this 0 won't mess with anything. So -3 times row 3 plus row 2 to be my new row 2. So row 1, row 3 will remain the same, and my new row 2 will be -3 times this row plus R2. So -3 times 0 plus 0, -3 times 0 plus 1, -3 times 1 plus 3, and then -3 times 3 plus 10. So now row 3 is where I want it. Row 2 is where I want it. Row 1, not quite there. I need to get rid of this 3. So I'm going to take -3 times row 2 and add that to row 1 to make my new row 1. Row 2, row 3 will remain the same. So I'm going to take -3 times row 2 plus row 1, -3 times row 2 plus row 1, -3 times row 2 plus row 1, and -3 times row 2 plus row 1. Now I'm almost there, but I really need to make this value a 0 also. So I'm going to take R3 plus R1 to be my new R1. Row 2 and 3 will remain the same. So for my new row 1, I'm simply adding these values together, adding those together, adding those together, and adding those together. And so I find my solution of 2, 1, 3, which was my ordered triple that I came up with previously.